Welcome to the sleepy god, a realm where silence carries the weight of centuries and light itself. Tells stories older than any civilization on Earth. Tonight, we step far beyond the familiar skies, past the horizon of our solar system, past the faintest glow of our neighboring stars, into a stage where entire galaxies wander like drifting continents across an endless ocean. Sometimes, these vast cities of stars cross paths, and when they do, something extraordinary unfolds. Collisions, not of chaos, but of transformation. At first, the very phrase galactic collision feels misleading, even violent. To the human ear, it conjures images of fire and ruined stars smashing into one another, planets cast into darkness, worlds annihilated in an instant. But this is a trick of language, an attempt to compress a cosmic timescale into human imagination. The truth is stranger and infinitely more graceful. These encounters unfold not in seconds, but in billions of years. They are not crashes, but slow-motion ballets, where galaxies swirl, bend, and stretch into new shapes under the quiet direction of gravity. If you could stand outside time and watch this performance unfold, it would resemble not a battlefield, but a dance floor. Spirals approach each other like cautious partners, arms unfurling into delicate arcs of starlight. They circle, retreat, and approach again, until eventually they merge into a new form entirely. The stars themselves, those brilliant lanterns scattered across the dark, rarely touch. The distances between them are so vast that a single star might never meet another, even as the galaxies pass through each other like ghosts. What changes is the structure, the choreography, the rhythm of motion. And yet, within this serenity, lies power beyond comprehension. Black holes awaken at the hearts of colliding galaxies, feeding on streams of gas drawn inward. New stars ignite in bursts of brilliance, born from the compression of vast clouds of dust. Long ribbons of light arc outward like brushstrokes across the canvas of the universe. What seems like destruction at first glance is revealed as renewal, a reshaping of order, a reminder that endings are often beginnings in disguise. Tonight, as we drift deeper into this story, let us carry a single question with us. What really happens when galaxies collide? This is not simply a matter of astrophysics, it is also a meditation on change, on the inevitability of transformation in all things. For billions of years, before the first human carved symbols into stone, the Milky Way and Andromeda were already bound by fate, moving slowly toward one another across the abyss. Long before life stirred on Earth, their meeting was written in the fabric of the cosmos. So let your thoughts loosen. Imagine yourself gazing upward, not as an inhabitant of one small world, but as a witness to a universe in motion, a place where collisions do not mean endings, but the patient unfolding of new forms, where beauty is not rushed, but revealed only to those willing to wait across eons. The galaxies are speaking slowly in a language of light and gravity. Tonight, we listen. When we speak of galaxies, we are not simply speaking of stars. A galaxy is a vast congregation, billions, sometimes trillions, bound together by gravity into a single, immense city of light. Each galaxy contains suns with their planets, nebulae, where stars are born, remnants of supernova where stars have died, clouds of dust and gas drifting like unseen streets, and at the very heart, the quiet gravitational anchor of a black hole. To stand on Earth and look up at the band of the Milky Way is to peer into the bustling downtown of our own galactic city, a metropolis so large that light, traveling at 300,000 kilometers per second, needs 100,000 years to cross it. from one side to the other. But galaxies are not static. They are alive with movement. Stars orbit like citizens along invisible roads, circling the galactic core. Clouds of gas drift, collide, and collapse to form new suns. Globular clusters, like ancient neighborhoods, cling tightly together, holding memories of the earliest epochs of creation. And all of this, the spiraling arms, the glowing center, the faint halo, is surrounded by something stranger still, an invisible substance called dark matter. Though unseen, dark matter is no less real. It forms a hidden scaffold that cradles each galaxy, providing the unseen structure upon which the luminous matter hangs. Without it, the galaxies would fly apart, their stars flung into the void. To imagine a galaxy, then, is to imagine not a single story, but a civilization of stories. Each star a stage for its own drama of birth, life, and death. Each planet, perhaps a world with oceans, mountains, and skies. Consider this: in the Milky Way alone, there may be more planets than stars, numbering in the hundreds of billions. To think of galaxies is to think of possibility itself, multiplied across the cosmos. If Earth is a village, then a galaxy is a continent. And yet, in the quiet scale of the universe, even a galaxy is but one island among countless others. Astronomers estimate there are at least 2 trillion galaxies in the observable universe, so many that if every one were a grain of sand, they would fill the palm of your hand, and you would still be staring at only a fraction of the whole. This is where perspective shifts. Our Milky Way, vast and luminous, is not unique in its grandeur. It is ordinary, and yet within this ordinariness lies something extraordinary. It is home. It is the stage upon which all human history, every poem, every battle, every birth and death, has unfolded. When we gaze upward at its hazy band stretching across a summer night, we are reminded of both our smallness and our belonging. The ancients sensed this truth long before telescopes confirmed it. To the Greeks, the Milky Way was the milk of Hera, spilled across the sky. In China, it was the Silver River, the heavenly crossing that separated the cowherd and the weaver girl, destined to meet only once a year when the magpies formed a bridge. To the Maya, it was the great ceiba tree, its roots in the underworld, its branches in the heavens. Across cultures, the galaxy became a mirror of life, fertility, love, fate, and the eternal passage between worlds. And so, as we step deeper into this journey of collisions and creation, let us keep this vision in mind. Galaxies as cities of light, each one carrying not just stars, but the seeds of stories, myths, and possibilities. They are not simply astronomical objects, they are the great libraries of the cosmos, containing within their spirals the history of everything that has been, and everything that may yet come to be. When we look beyond our own galactic home, we discover that galaxies, like cities, come in many forms. Some are elegant spirals, their arms coiled gracefully around a glowing core. Others are giant ellipticals, smooth and featureless, resembling vast orbs of starlight. Still others are irregular, their shapes chaotic, as if caught mid-sentence in some cosmic dialogue. Spiral galaxies, like our own Milky Way, are the archetypes of celestial beauty. Their arms are rivers of young stars, blue and hot, tracing delicate arcs outward. These arms are not static structures, but waves of density moving through the disk. Much like ripples in water, compressing gas and triggering bursts of star formation. It is here, in the spiral arms, that cosmic nurseries flourish, where hydrogen clouds collapse into new suns and planetary systems. To see a spiral galaxy is to see life in progress, a city of light under constant renewal. Elliptical galaxies, by contrast, are the monuments of time. They are larger, older, and quieter, composed mostly of ancient red stars that have long since exhausted the raw gas needed to birth new generations. Their smooth shapes are the product of collisions and mergers, the sculpted remains of galaxies that once spiraled but were pulled together into a single, massive whole. They are like the ruins of old civilizations, still grand, still luminous, but hushed, their fires dimmed. And then there are the irregulars, galaxies without symmetry, without pattern. They are the outcasts of the cosmic order, often distorted by the pull of nearby neighbors or shaped by violent encounters. Some are small and scrappy, their starlight uneven, like campfires scattered in the night. Others blaze with chaotic energy, raw places where gravity and turbulence create something entirely unpredictable. Galaxies also vary immensely in size. Dwarf galaxies, some containing only a few billion stars, cling to the edges of larger galaxies, like satellites. Our Milky Way has dozens of such companions, the most famous being the Large and Small Magellanic Clouds, irregular, faint, but beautiful in their own right. In the southern skies, these clouds drift like detached pieces of the Milky Way, reminders that even great galaxies are seldom alone. On the other extreme lie giants like IC 1101, an elliptical galaxy spanning more than 400,000 light-years, containing hundreds of trillions of stars, a city so vast it defies comprehension. Yet regardless of form or size, galaxies are both fragile and resilient. They can be bent, stretched, and reshaped by encounters with others, yet the stars within them continue to orbit calmly, unbothered by the larger drama. Imagine an empire collapsing, borders erased, governments toppled, and yet each citizen carries on with daily life, unaware of the seismic shifts in power. So too with galaxies. Their grand structures may be rewritten, but their stars shine on, indifferent to the fate of the whole. For the human mind, there is something deeply humbling in this diversity. We live in one spiral among trillions, and while it feels unique to us, it is but one expression of the cosmic imagination. Galaxies are not bound to a single design. They are endlessly inventive, each one with its spirals, ellipses, or ragged edges, is a reminder that beauty in the universe comes not from uniformity, but from variety. And perhaps, when we marvel at these forms, we are really marveling at reflection, the universe expressing, in its vastness, the same diversity we see in ourselves. Cities differ, cultures differ, faces differ. So too do galaxies. It is their many forms that give the cosmos its endless wonder. There was a time, not so long ago, when even the most learned minds could not agree on what galaxies truly were. For centuries, astronomers saw faint, misty smudges scattered across the night sky. Through the telescopes of the 18th and 19th centuries, these smudges looked like clouds of light, so they were called nebulae, Latin for cloud. To some, they were star clusters within the Milky Way, mere ornaments decorating the edge of our galactic home. To others, they were something far grander, entire island universes, floating beyond the reach of our own. This debate raged well into the early 20th century. Astronomers such as Harlow Shapley argued that the Milky Way contained everything, that these nebulae were simply nearby gas clouds or clusters. Others, like Heber Curtis, insisted that they were independent galaxies, vast and separate, existing far outside our own. The stage for discovery was set, but proof was still elusive. The breakthrough came with Edwin Hubble. In 1924, using the powerful Hooker telescope at Mount Wilson Observatory, Hubble studied the Andromeda Nebula. What he found changed our view of the universe forever. Nestled within Andromeda, he identified Cepheid variable stars, stars whose brightness fluctuates with predictable rhythms. By measuring their pulses, Hubble calculated their distance, and the numbers told a story no one could ignore. Andromeda was not within the Milky Way. It was far, far beyond, millions of light years away. With that revelation, the universe expanded overnight. The Milky Way, once thought to be the entire cosmos, was revealed as just one among countless galaxies. The smudges that peppered the night were not nearby clouds, but distant cities of stars, each one unimaginably vast. The human perspective shifted in an instant from believing we lived in the whole of creation, to realizing we inhabited one corner of a universe filled with trillions of worlds. The phrase island universes suddenly became more than a metaphor. Galaxies were indeed islands, floating in the black seas of space, separated by gulfs so wide that even light requires millions of years to cross them. Imagine, for a moment, how this must have felt for those alive in the 1920s. Humanity had just harnessed electricity, built automobiles, and reached across continents with radio. And yet, while modernity was dawning on Earth, Hubble's work revealed that our place in the cosmos was smaller and stranger than anyone had dreamed. Even today, this discovery carries a shock. When you look at a clear night sky, the stars you see belong almost entirely to the Milky Way. Only two galaxies, the Large and Small Magellanic Clouds, are visible to the naked eye from southern latitudes. And yet, with telescopes, we now know there are at least 2 trillion galaxies in the observable universe, each one a realm of stars, gas, dust, and dark matter. Each one a universe unto itself. The debate of the island universes reminds us of something profoundly human, the limits of perception. For centuries, we mistook galaxies for clouds because we lacked the tools to see more clearly. How many other truths still hide in plain sight, waiting for discovery? How much of the universe is still invisible to us, not because it does not exist, but because we do not yet know how to look? It is a humbling thought, one that whispers gently every time we glance upward. The smudge of Andromeda in the night sky, so faint, so ordinary, was once at the heart of a great scientific debate. Now we know it as a sprawling galaxy of 1 trillion stars, a neighbor moving ever closer to our own. And with that knowledge, we are reminded the universe is always larger than our imagination. If galaxies are the grand cities of the cosmos, then who or what are their architects? What invisible hands draw their spirals, carve their ellipses, and hold their fragile structures together across billions of years? The answer lies in 2 forces, both familiar and mysterious: gravity, the ancient master we have always known, and dark matter, the unseen sculptor whose presence we feel but cannot yet touch. Gravity is the oldest storyteller in human history. Isaac Newton first gave it words in the 17th century, describing it as the force that pulls the apple to the ground and the moon around the earth. Centuries later, Albert Einstein deepened the tale, showing us that gravity is not simply a pull but the very bending of space-time itself. Massive objects curve the fabric of reality, and smaller bodies follow those curves like dancers tracing invisible lines. It is this constant bending, this patient tugging, that shapes galaxies into the forms we see today. Without gravity, stars would scatter into the void, gas clouds would drift apart, and galaxies would never cohere. But gravity alone cannot explain what astronomers observe. In the mid-20th century, scientists began studying the way galaxies spin. They expected that stars at the edges would move more slowly than those near the center, much as planets orbiting the sun move at speeds determined by their distance. Instead, they found something shocking. Stars at the outskirts of galaxies were moving just as fast as those near the core. By Newton's laws, this should have been impossible. The galaxies should have torn themselves apart. The explanation pointed to something unseen, a vast halo of invisible matter surrounding each galaxy, outweighing the visible stars by a factor of 5. This dark matter, so named because it neither emits nor absorbs light, forms the hidden skeleton of the universe. Though it makes up the majority of a galaxy's mass, it remains invisible to our eyes and instruments. We know it only by its influence, the way it holds galaxies together, the way it bends light from distant objects, the way it sculpts the large scale. The structure of the cosmos. To imagine dark matter is to imagine a kind of invisible scaffolding, a framework upon which galaxies are hung like lanterns. Without it, the universe would look very different. The delicate spirals we admire would not exist. The galaxies themselves might never have formed. Dark matter is the silent architect, building in shadow, guiding creation without ever revealing its face. And yet, for all its importance, we still do not know what dark matter truly is. Some propose exotic particles that slip through ordinary matter like ghosts. Others imagine primordial black holes, ancient remnants of the early universe. We build detectors deep underground, shielded from radiation, waiting for a whisper of its presence. But so far, it remains just out of reach, a mystery written across the sky in patterns we cannot deny, but cannot yet explain. What we do know is this: gravity and dark matter together are the great sculptors of galaxies. Gravity bends, dark matter holds, and the result is the universe as we see it, a tapestry of light woven across darkness. In their partnership lies the paradox of existence, the visible and the invisible, the known and the unknown, shaping creation hand in hand. When we look at the night sky, we are seeing only a fraction of what is there. The stars are the visible notes of a hidden symphony, but the music itself is carried by something silent, something unseen. To understand galaxies, we must accept that what is brightest is not always what is most important. Sometimes it is the unseen that defines the shape of everything. Step back further than you have ever imagined, beyond the Milky Way, past Andromeda, beyond clusters of galaxies tied together in invisible bonds. From this impossible vantage, the universe no longer appears as scattered points of light, but as a vast structure, threads and knots stretching across space like an infinite spider's web. This is the cosmic web, the grand architecture of the universe. Here, galaxies are not isolated wanderers. They are arranged in filaments, long strands, of clustered galaxies and dark matter, sometimes stretching hundreds of millions of light years. At their intersections lie dense knots, galaxy clusters, the crowded cities of the cosmos. Between these filaments are the voids, immense expanses of near-nothingness, where only a few galaxies drift, lonely and far from their kin. The first hints of this structure came in the late 20th century, when astronomers began mapping the distribution of galaxies across the sky. Instead of finding them sprinkled randomly, they discovered a pattern: walls and chains, arcs and bubbles, vast shapes, spanning unimaginable distances. The largest of these structures, the Hercules corona, Borealis Great Wall, stretches over 10 billion light-years, so large that light itself has only just had time to traverse it since the birth of the cosmos. And yet, for all its scale, the cosmic web has a quiet elegance. It resembles the filaments of a brain, the threads of mycelium spreading beneath a forest floor, or the strands of a spider's silk glistening in morning light. In every case, structure emerges from connection. Galaxies are not scattered like dust, they are woven into a larger whole, guided by the interplay of gravity and dark matter. Within this web, galaxies are travelers. They drift slowly along the filaments, pulled ever toward denser regions, like rivers flowing into seas. When they meet at the nodes, clusters' collisions become inevitable. Whole galaxies fall into one another's embrace, shaping their futures in ways that can only be understood against this larger backdrop. Our own Milky Way is no exception. It resides in the local group, which itself is bound to the Virgo which in turn is part of the Laniakea supercluster, a Hawaiian word meaning immense heaven. Even the names remind us of our smallness against such grandeur. But perhaps the most haunting truth of the cosmic web is this: it is fleeting. Over billions of years, gravity continues to draw galaxies closer, while dark energy, the mysterious force driving the accelerated expansion of the universe, pulls them apart on larger scales. The web we see today is not eternal. Like frost patterns on a window pane, it is delicate, temporary, and beautiful precisely because it will not last forever. To glimpse the cosmic web, then, is to glimpse the universe, not as a collection of objects, but as a living structure. A network of connections that binds the cosmos together across unimaginable gulfs of time and space. And in its quiet geometry, there lies a whisper that feels almost human. Nothing exists in isolation. Not galaxies, not stars, not even us. The story of galaxies begins not with spirals and ellipses, but with chaos. In the first moments after the Big Bang 13.8 billion years ago, the universe was a hot, dense sea of particles, expanding and cooling. There were no stars, no clusters, no light to soften the darkness. Only hydrogen and helium, drifting in a vast, featureless fog. Yet even in that apparent uniformity, there were tiny imperfections, minute ripples in density, no larger than 1 part in 100,000. They were almost nothing, invisible to the eye, but they were the seeds of everything to come. Under the patient hand of gravity, these slight variations grew. Dense regions pulled in more matter, while emptier regions thinned into voids. Slowly, invisibly, structure began to emerge. The first galaxies were nothing like the grand spirals we admire today. They were small, irregular, turbulent. Vast clouds of gas collapsed into stars, many of them massive and short-lived. These first stars, known as population 3 stars, burned hot and died young, exploding as supernova that seeded their surroundings with heavier elements, carbon, oxygen, iron. It was this enrichment, spread through stellar death, that made the next generations of stars capable of forming planets, oceans, and life itself. Imagine it, the early universe, as a restless workshop, where galaxies took shape not through calm design, but through violent trial and error. Proto-galaxies collided frequently, merging into larger systems. Their shapes were ragged, their structures unstable. But with each merger, with each cycle of birth and death, galaxies grew more complex, more organized. It is almost as if the universe practiced on small canvases before painting its masterpieces. The spirals we see today, the Milky Way, Andromeda, Whirlpool, are the result of billions of years of refinement, of repeated collisions that smoothed rough beginnings into elegant forms. Just as civilizations rise from scattered tribes, galaxies rose from these early clusters, gathering into larger and more coherent forms. The James Webb Space Telescope has given us glimpses of this infancy, tiny redshifted smudges that are in fact some of the earliest galaxies ever born. They look fragile, almost ghostly, and yet they are the ancestors of everything. Our Milky Way, too, began as a collection of such fragments, slowly built up through countless mergers. Even now, it continues to feed on smaller galaxies, consuming them quietly as if remembering its origins. There is a deep humility in this story. Everything familiar, the sun, the earth, the atoms in our blood, emerged from those first chaotic clouds, from stars that lived and died long before our galaxy found its present shape. We carry within us the memory of the universe's earliest days. To look at a galaxy is to look at ancestry written across the sky, not only the ancestry of stars, but of ourselves. In the beginning, galaxies were not elegant. They were experiments, rough drafts, fragile sketches. And yet, from that restless beginning emerged the beauty we now admire. The Origins of Galaxies remind us that perfection is not immediate, it is forged slowly. Through struggle, patience, and countless transformations, galaxies do not grow old in solitude. From their very beginnings, they have lived in a universe of constant encounters, drawn together by gravity, reshaped through collisions, and reborn in forms they never could have achieved alone. To understand galactic evolution is to understand a story not of isolation, but of contact, sometimes violent, often beautiful, always transformative. In the early universe, collisions were far more common than they are today. Space was younger, galaxies closer, their paths crossing again and again like travelers on a crowded road. Each time they met, the delicate balance of their structures was upset. Spirals, twisted arms stretched into long ribbons of stars, called tidal tails, and clouds of gas were compressed into bursts of new star formation. These cosmic encounters lit the darkness with fresh suns, galaxies turning briefly into starburst factories, their glow visible across billions of light years. Over time, these meetings changed not just appearance, but destiny. When two spirals collided, their swirling arms often unraveled, leaving behind the smooth ellipses we see dominating the universe today. Elliptical galaxies are the silent monuments of such ancient mergers, vast, red, and quiet, filled with old stars that speak of once chaotic beginnings. If spirals are youthful cities, full of vitality and renewal, ellipticals are their older cousins, dignified, weathered, no longer birthing new generations, but carrying the weight of memory. Our own Milky Way is no stranger to this dance. It has consumed smaller galaxies again and again, a process astronomers call galactic cannibalism. Streams of stars, remnants of devoured companions, still trace faint arcs across its halo like ghostly signatures of past meals. Even now, the Sagittarius dwarf galaxy is being pulled apart, its stars stretched into a ribbon that winds through our sky. To live within the Milky Way is to inhabit not a static structure, but a story still unfolding. A city whose foundations were laid by countless predecessors. Andromeda, our nearest large neighbor, carries the same history. It too has grown by swallowing smaller companions, becoming the great spiral we see today. Its halo is littered with stellar debris, signs of the many galaxies it has consumed. In this way, growth through encounters is not a rare event, but the very method by which galaxies evolve. Just as ecosystems thrive through exchange, just as cultures grow through contact, galaxies too are shaped most profoundly by what they meet along the way. There is a lesson in this. Collisions are not endings, but transformations. The galaxies we see today are mosaics made from countless ancestors, their light woven together into something larger than any single beginning. Evolution in the cosmos is not gentle, but it is purposeful. Out of chaos, order emerges. Out of encounters, new beauty is born. The Milky Way itself, vast and luminous, is a survivor of this long history of mergers, and yet its greatest transformation still lies ahead, the inevitable meeting with Andromeda, a collision written into the future of our skies. What seems stable is always changing. What feels eternal is only passing through a stage in the great cycle. To study galactic evolution is to learn that survival does not mean remaining the same. It means becoming something new. To speak of galaxies is to speak of time on scales that dwarf human imagination. Our species measures history in years, centuries, at most a handful of millennia. We mark eras by the rise and fall of civilizations, the carving of monuments, the writing of books. Yet in the language of the cosmos, such spans are no more than fleeting breaths. Consider this: dinosaurs roamed the earth 65 million years ago, an age so distant it feels impossible to grasp. And yet, from the perspective of the Milky Way, that was yesterday. In those 65 million years, the Sun has moved less than 1% of the way around the galaxy. A single orbit of our star around the Milky Way, the so-called galactic year, takes about 225 million Earth years. Since the Earth formed 4.5 billion years ago, we have completed only about 20 of these galactic years. Humanity itself has existed for less than a blink of the current one. When galaxies collide, they do so not in seconds, but over spans measured in hundreds of millions, even billions of years. To us, such a collision sounds like a sudden catastrophe, but to the universe, it is a slow unfolding, a ballet whose steps take longer than all of human history combined. Stars arc gracefully, tidal tails stretch outward like ribbons, black holes spiral together, and only after unimaginable ages does a new galaxy emerge from the encounter. It is humbling to realize that in the time it takes for two galaxies to merge, entire species may rise and vanish on their planets. Civilizations may appear, flourish, and disappear without ever witnessing the beginning and end of the dance above them. On Earth, we record the passing of centuries with cathedrals and ruins. The universe records the passing of eons with the merging of galaxies. This perspective is not meant to diminish us, but to reframe us. Our lives may be brief compared to the slow heartbeat of the cosmos, but they are no less real. To live is to shine for a moment, like a star seen from far away, a flicker that may last only an instant in the grand design, but whose light is still part of the whole. When we gaze up at the night sky, we are not only looking outward, but backward. The light of Andromeda, visible as a faint smudge to the naked eye, has traveled for more than 2 million years to reach us. We see it not as it is now, but as it was before our species even existed. Every star, every galaxy we observe is a message from the past, a reminder that time in the cosmos flows differently than in our brief human span. Perhaps this is the quiet gift of astronomy. It teaches patience. It reminds us that change, though inevitable, often unfolds in ways we cannot witness directly. The universe does not rush. It writes its stories slowly, with ink made of light and time. And if we listen closely, those stories offer comfort. They remind us that impermanence is not loss, but transformation, that the fleetingness of our lives is part of a rhythm older than the stars themselves. When most people hear the phrase galactic collision, the mind leaps to visions of chaos, stars smashing into one another, planets ripped from their suns, whole worlds destroyed in sudden fire. Yet the truth is stranger, subtler, and in many ways more beautiful. The science of galactic collisions reveals not catastrophe, but transformation, a choreography directed by gravity across unfathomable spans of time. The first fact to understand is scale. Stars within a galaxy are separated by immense distances. If our Sun were the size of a grain of sand, the nearest star, Proxima Centauri, would lie several kilometers away. With such emptiness between them, the chance of two stars physically colliding during a galactic merger is vanishingly small. Galaxies can pass through each other almost like ghosts, their stars weaving past one another unharmed. What does collide are their invisible halos, their vast clouds of gas, and their envelopes of dark matter. These invisible structures interlock, tug, and stretch, setting the stage for transformation. When galaxies interact, gravity acts like a sculptor's hand. Stars are pulled into great arcs and streams, forming luminous tidal tails that trail for hundreds of thousands of light years. Their disks warp and twist. In some cases, they form bridges of stars between them, glowing corridors across the void. These shapes are not random, but follow precise mathematical patterns, governed by Newton's laws and Einstein's curved spacetime. To simulate them on a computer is to watch art emerge from equations. Perhaps the most dramatic consequence of collisions is what happens to gas. Galaxies contain vast reservoirs of hydrogen, the raw material of stars. When two galaxies pass through each other, their gas clouds are compressed, like rain clouds colliding in Earth's sky. This compression triggers storms of star birth. Entire generations of stars ignite at once, blazing into being in what astronomers call a starburst. Some starburst galaxies create hundreds of new stars every year, a frenzy of creation compared to the calm pace of normal spirals like the Milky Way, which makes only a few dots at the same time. Central black holes often awaken as gravitational tides funnel gas toward the cores. These supermassive black holes gorge themselves, releasing titanic amounts of energy. The galaxies flare with quasars, their centers outshining all their stars combined. For a brief moment in cosmic time, they burn like beacons visible across billions of light years. Yet what emerges from these encounters is not destruction but renewal. Two spirals may lose their graceful arms, but they gain a new identity as an elliptical galaxy, smooth and enduring. Others retain their disks but are reshaped, their structures more complex than before. Each collision adds to the tapestry of the universe, weaving stories of birth, death, and rebirth in light. For centuries, humans feared the idea of the heavens in turmoil. The stars, after all, were supposed to be eternal, unchanging, perfect. But the science of galactic collisions reveals a deeper truth. Change is not an exception in the cosmos, it is the rule. The universe is not a static stage, but a restless workshop, forever reshaping itself. And we, too, are participants in that story, living within a galaxy whose own future is already written in the language of gravity. To call a galactic collision a crash is to miss the truth. These events are not explosions in the night, but slow, unfolding ballets, vast choreographies, measured not in seconds or minutes, but in millions of years. Imagine two spirals approaching each other, their arms unfurling like dancers stretching before a performance. They circle, retreat, return again, each pass reshaping their forms. What emerges is not wreckage, but a new dance, entirely something neither galaxy could have become. Alone, elliptical galaxies are perhaps the most enduring monuments to this cosmic ballet. Their smooth, rounded shapes are the fossils of ancient unions, spirals merged and remade. In their vast halls, old stars glow like quiet embers. And though they are no longer places of frantic birth, they radiate a dignity born from history. They are the elder dancers of the cosmos, their performance long concluded, but their presence still commanding. Yet not all collisions end in quiet. Sometimes they awaken what has long been dormant. At the heart of nearly every galaxy lies a supermassive black hole. Dark engines, millions or even billions of times the mass of the Sun. In ordinary times, these black holes may rest in silence, invisible against the glow of surrounding stars. But a collision changes that. Gas is funneled inward, spiraling down like water into a drain, feeding the black hole. As it consumes, it releases torrents of energy, igniting the core of the galaxy. Into a quasar, a beacon so bright it can outshine the combined light of every star within. For a brief, cosmic moment, the galaxy becomes a lighthouse across the universe, and the stars themselves, though rarely colliding, respond to the gravitational tides in their own way. Some are cast into long arcs, tidal streams stretching like ribbons of silk. Others are flung into intergalactic space, becoming wanderers with no home, doomed to drift forever between galaxies. These exiles remind us that every dance carries with it both beauty and loss. To watch simulations of these encounters is to be entranced. Spirals collide, arms twist, bridges form, and tails sweep outward in curves too perfect to be accidental. There is elegance even in their violence, an artistry written in equations of motion and gravity. Human dancers rehearse for months to achieve synchronicity. Galaxies rehearse for billions of years, and their stage is the universe itself. Perhaps what is most astonishing is the patience of it all. We tend to imagine creation as sudden a spark, a flash, a singular moment of becoming. But the universe reminds us that creation can be slow, deliberate, unfolding step by step across ages. Galaxies are not destroyed in collisions. They are transformed, their destinies rewritten. What we mistake for endings are only movements in a larger dance. And so, the phrase Ballet of Creation is not metaphor alone. It is truth. Galaxies collide, not in chaos, but in rhythm, their shapes bending to a choreography older than the Earth itself. When we look upward and see the faint glow of a spiral, or the hazy light of an elliptical, we are not just seeing a galaxy, we are seeing a performance frozen in mid-step, a dance that began long before us and will continue long after. Among the many encounters written across the universe, few are as striking to the human eye as the Antennae galaxies. Located some 60 million light-years away in the constellation Corvus, they are two spirals locked in the embrace of collision. Their shapes pulled into sweeping arcs that extend like great insect antennae across space. To see them through a telescope is to witness a moment of drama frozen in time, a cosmic portrait of transformation at its most vivid. The Antennae were once two ordinary spiral galaxies, not unlike the Milky Way or Andromeda, but as gravity drew them together, their delicate disks began to distort. Their stars were stretched outward into luminous streams, forming the great antennae that give the system its name. These tidal tails, extending hundreds of thousands of light-years, are among the most beautiful structures in the visible universe, ribbons of starlight, unraveling against the darkness. But the true wonder of the antennae lies not in their shape alone, but in the firestorm of creation ignited within them. As the galaxy's vast gas clouds collide and compress, they trigger an eruption of star formation. New suns are born by the millions, clustered in glowing nurseries that blaze like jewels. The antennae are what astronomers call a starburst galaxy, creating stars at a rate dozens of times faster than our Milky Way. For now, they are young and chaotic, their cores still distinct, their shapes tangled. But in time, they will merge into one, a massive elliptical galaxy, smooth and luminous, their tumultuous youth preserved only in memory. To study the antennae is to glimpse not only the beauty of collision, but also the process by which galaxies grow. Each new star born within them carries the heavy elements forged in earlier generations of stars. Carbon, oxygen, iron, the building blocks of planets and life, are scattered across their arms, waiting for the future. In the fiery clouds of the antennae, the ingredients of tomorrow's worlds are already being assembled. Somewhere in that chaos, perhaps, lie the seeds of life that may one day awaken to gaze back at the stars. What makes the antennae so compelling is their immediacy. We are catching them mid-dance, at a stage our own galaxy and Andromeda will one day experience. To look at them is to see the future written in the heavens, a mirror held up across millions of light years. In 4 or 5 billion years, the night sky from Earth, or whatever worlds survive, will look much like this. Arcs of starlight stretching outward, new suns igniting, the Milky Way reshaped by its embrace with Andromeda. And so, the antennae are more than an astronomical curiosity. They are a lesson in patience, a reminder that creation often appears violent only because we are too small, too brief-lived to see the grace within. What seems like chaos is, in truth, choreography. The antennae. Galaxies are not wreckage, but promise, the promise that from collision comes renewal, from change comes beauty. Not all galactic encounters end in tangled chaos. Some reveal themselves in shapes so precise, so breathtaking, that they seem less like accidents of gravity and more like deliberate works of art. Among these is the Whirlpool galaxy, also known as M51, lying about 23 million light-years away in the constellation Canes Venezia. To gaze upon it is to see a spiral galaxy in its prime, its arms unfurling with mathematical elegance, its structure almost too perfect to be real. The Whirlpool is famous not only for its beauty but also for its companionship. Attached to it, like a smaller dancer drawn into orbit, is a dwarf galaxy, NGCA 5195. The two are locked in a gravitational embrace. The smaller galaxy has passed through Whirlpool's disk before, disturbing it, tugging at its arms, and setting off waves of star formation. It is this interaction, scientists believe, that has given Whirlpool its extraordinary clarity, the sharp sweep of its spiral arms, glowing with clusters of hot, young stars. In other words, its beauty is not an accident, but the result of collision. This partnership between the Whirlpool and its companion is a quieter echo of the grander mergers like the antennae. It is less violent, less chaotic, but no less significant. Each time the smaller galaxy makes its pass, it pulls on the Whirlpool's structure, stirring its gas, breathing life into new generations of stars. The result is a galaxy that shines, like a celestial garden in full bloom through telescopes. The Whirlpool's arms reveal knots of pink nebulae, star-forming regions where hydrogen gas collapses into clusters of newborn suns. Between these nurseries lie lanes of dark dust, curving like rivers through the spiral, giving contrast and depth. To trace these arms is to trace the story of renewal, written in light across tens of thousands of light years. But like all dancers, this too will change. The dwarf companion will not orbit forever. In time, it will merge fully into the whirlpool, losing its identity, becoming part of the larger whole. The galaxy we admire today, so orderly and defined, is only a stage one act in a story that will end in transformation. Perhaps it will grow into a larger spiral, or perhaps, after future encounters, it too will become an elliptical. Beauty in the universe is never permanent. It is always becoming. For us on Earth, the whirlpool has carried meaning beyond science. Discovered in the 18th century by Charles Messier, it has been a favorite of stargazers ever since, a reminder that order exists in the heavens even amidst chaos. To amateur astronomers, its spiral is a symbol of cosmic harmony. To scientists, it is a natural laboratory, showing in real time how galaxies interact and evolve. And to poets and dreamers, it is simply what its name suggests, a whirlpool of stars, a spiral beckoning the imagination into its depths. The Whirlpool galaxy shows us that collisions need not always be destructive. Sometimes they refine, clarify, even beautify. It is a reminder that the universe is not only a place of violence but also of grace, that within the slow steps of its dancers, there can emerge shapes so perfect that they take our breath away. If the Antennae galaxies are a portrait of chaos and the Whirlpool a vision of elegance, then the Cartwheel galaxy is something else entirely. An explosion frozen in time, a ripple of creation written across the sky, located about 500 million light years away in the constellation Sculptor. It is one of the strangest and most striking galaxies ever seen, a perfect ring of light, encircling a ghostly core, like the splash of a stone in a cosmic pond. The Cartwheel was once an ordinary spiral galaxy, not unlike our own. But then, perhaps a few 100 million years ago, another galaxy, smaller but dense, plunged directly through its heart. The impact did not shatter it. Instead, it sent a shock wave racing outward through the disk, compressing gas as it went. The result was a ring of furious star formation, a brilliant circle of blue, hot newborn stars that still blaze today. Behind it, like ripples spreading across water, lies the faint afterglow of older stellar waves. This kind of structure is rare. While tidal tails and bridges are common in galactic interactions, a perfect ring is unusual, requiring a direct hit. That is what makes the Cartwheel so mesmerizing. It is a singular moment, a frozen instant of collision that will not last forever. Over the coming billions of years, the ring will dissipate, the galaxy reshaping itself into something calmer, more ordinary. What we see now is fleeting, a burst of beauty caught between two stable forms. And yet, even in its strangeness, the Cartwheel tells us something profound about how galaxies evolve. Collisions are not uniform. They write different stories depending on angle, speed, and mass. Sometimes they tangle spirals into antennae. Sometimes they refine arms into whirls. And sometimes, with exquisite precision, they draw rings of light across the universe, as if reminding us that even in chaos, geometry can emerge. To peer at the Cartwheel is also to see contrast. Its central core is dim and ghostly, filled with older stars, while the ring around it blazes with youth and color. It is as though the galaxy is wearing a crown of fire, a circle of renewal surrounding an aging heart. This duality, age and youth, silence and brilliance, makes it a living metaphor for the cycle of creation itself. Astronomers have studied the Cartwheel with fascination, using it as a natural experiment to test theories of galactic dynamics. But, beyond equations, it leaves an impression that is almost artistic. From Earth, its form is so perfect, so startlingly symmetrical, that it hardly seems natural. It looks like something drawn, a symbol rather than an accident, as if the universe itself sketched it across the night. And perhaps that is why the Cartwheel stays with us. It is not only a collision, it is a moment of cosmic art, a shape we recognize, a reminder that the universe speaks in patterns we can understand. Where we expect chaos, we sometimes find design. Where we expect destruction, we find creation. The Cartwheel galaxy is proof that the universe, in its endless transformations, can be both violent and exquisitely beautiful at once. It is easy to think of galactic collisions as events that happen out there in distant corners of the universe, far removed from our quiet existence here on Earth. But this illusion of isolation is just that, an illusion, for written into the very future of our own night sky is an event as grand as any we've witnessed in the distant cosmos. The coming collision between the Milky Way and the Andromeda galaxy. Andromeda, that faint, misty smear of light, visible to the naked eye on dark nights, is not a distant observer. It is on a direct path toward us, closing the 2.5 million light-year gap at a speed of roughly 110 kilometers per second. The galaxies are gravitationally bound. Their meeting is inevitable, and it has already begun in about 4 billion years. The two spirals will begin to merge. What follows will not be a sudden crash, but a prolonged embrace. Over several billion more years, they will circle, pass through one another, pull apart, and come together again. Their elegant arms will tangle. Gas clouds will compress, igniting new waves of star formation. And though their stars will mostly pass by one another, their paths will be forever changed, flung into new orbits, some even ejected into intergalactic space. For Earth, the consequences will be spectacular but not apocalyptic. The Sun itself may be flung into a new orbit, perhaps higher above the galactic plane. Our night sky will transform, filled with arcs of stars and nebulae as the galaxies draw closer. Imagine looking up to see Andromeda not as a small blur, but as a vast structure stretching across the heavens, its spiral arms luminous and near. Later, those arms will be distorted, forming tidal tails, bridges, and knots of light. It will be the greatest light show the Earth has ever seen, if it still exists. By the time the collision reaches its peak, the Sun will be nearing the end of its life. It will have become a red giant, possibly engulfing the inner planets and rendering Earth uninhabitable. Whether or not humanity or its descendants witnesses the merger, the cosmos will go on shaping its grand narrative. Uncaring and beautiful, that the result of the merger will be a new galaxy, often referred to by astronomers as Milky or Andromeda. It will be larger, likely elliptical in shape, a product of two ancient spirals finally unified. Over time, the remnants of both galaxies, stars, gas, dark matter will settle into this new form, quieter and redder, no longer birthing stars at the same rate, but glowing with the memory of what once was. The story of the Milky Way and Andromeda is not unique. It is a chapter repeated across the universe, but it is our chapter. It ties us to the larger cosmos, not as spectators, but as participants. We are not watching the ballet of the galaxies from a distance, we are dancing in it, and in that thought lies something profoundly moving. Our planet, so small, so brief in its existence, is riding within a galaxy that is on a journey through time and space. The stars above us are not fixed, they are flowing, falling, merging, becoming. To look up at the night sky is to look into a future written not in years, but in eons. A future in which everything we know will be transformed, not destroyed, but remade. When we speak of galaxies colliding, it is easy to become lost in the spectacle, the beauty, the violence, the sheer scale. But behind that spectacle lies something deeper, a map of how the universe works, a guide to its structure, its past, and its fate. Galactic collisions are not just dramatic events, they are evidence. They are data points in a cosmic equation we are only beginning to understand. First, they confirm the role of gravity as the architect of the universe. On the largest scales, it is gravity that shapes the fate of galaxies. Though stars within galaxies rarely collide, their motions are entirely governed by the mutual gravitational pull of billions of stars, clouds of gas, and the dark matter halos that envelop them. The intricate dances we see from spiraling mergers to perfect rings are not random. They are predictable, consistent with the laws Newton laid down and Einstein refined. Galactic mergers also reveal the hidden presence of dark matter. We cannot see dark matter directly, it emits no light, interacts with nothing but gravity. But in collisions like the famous bullet cluster, astronomers can trace its gravitational influence. As two galaxy clusters pass through one another, their luminous matter stars and hot gas slows and collides. But the dark matter, unaffected by friction, continues undisturbed. By mapping gravitational lensing, how the mass bends light, we see where the dark matter went. It proves what our equations suggest, that galaxies are not just made of what we can see. Most of their mass lies in the invisible. Then there is the question of galactic evolution. Observing galaxies at various stages of collision allows astronomers to reconstruct how galaxies change over time. We see spirals merging into ellipticals. We see dormant galaxies reignited by fresh infusions of gas. We see new stars born and others fading. Without collisions, galaxies would stagnate, their gas slowly consumed, their stars growing cold. It is the encounters planned by the hand of gravity that keep the universe dynamic. In this way, galactic collisions are not just events. They are instruments of renewal. They are how the universe resets the clock, redistributes its resources, and builds new structures from the old. Every time two galaxies meet, a new galaxy is born, not immediately, but slowly, patiently, across epochs. The old forms give way to new ones. Star clusters disperse, spiral arms vanish, but in their place come superclusters, halos, and grander scales of organization. Even the fate of our own universe is hinted at in these encounters. In a cosmos governed by expansion, gravity works. In opposition to that pull, drawing matter together while space itself stretches apart. The balance between these forces determines everything from whether galaxies merge to whether the universe expands forever or collapses back into itself. Watching galaxies collide is watching that tension play out in miniature. And finally, collisions teach us humility. They remind us that change is the rule, not the exception, that permanence is an illusion, that even the stars will one day fall into new arrangements, new forms, new destinies. For all our efforts to fix meaning to place and time, the cosmos moves on. But in that movement, there is grace. There is structure. There is story. To study galactic collisions is to read that story, not in words, but in light and gravity. And, though we will never live long enough to see one unfold from beginning to end, we are witnesses all the same, brief flashes of consciousness within a much longer tale. For all their enormity, galactic collisions are not locked away in some unreachable realm. From Earth, with nothing more than mirrors, lenses, and the quiet patience of human curiosity, we can observe them, capture them, even they are stories, not confined to theory or distant speculation. They are written in the night sky. Modern astronomy has made us privileged observers of these cosmic events. Telescopes like the Hubble Space Telescope, James Webb, and massive ground-based observatories across Chile, Hawaii, and the Canary Islands have opened our eyes to the distant universe. With long exposures and advanced sensors, they reveal not just single stars or planets, but entire galaxies, some in the middle of merging, others frozen in the aftermath. We can now see galactic collisions in exquisite detail, glowing arcs of star formation, plumes of gas flaring out like cosmic surf, central black holes bursting with quasar fire. These are no longer abstract ideas, they are photographs, time capsules of light that began its journey before humans existed. Every image is a message from the past, and every collision a frame in a movie whose full run lasts billions of years. For amateur astronomers, the journey is no less meaningful. Though distant galaxies appear faint, their forms can still be glimpsed with backyard telescopes. The Andromeda galaxy, for instance, is visible to the naked eye under dark skies, a constant reminder that we live in a galaxy with a destiny. Even a modest telescope can show the Whirlpool's perfect spirals or the glowing core of the Sombrero galaxy. It is enough to ignite wonder, but what truly connects us to these events is not just the ability to see them, it's the ability to understand them. Unlike generations past, we now know what these shapes mean. A warped spiral is not just strange, it is a galaxy mid-transformation. A faint halo around a bright core is not a mystery, it is a remnant of past mergers. We are not just observers of beauty, we are readers of a language written in light, and the more we look, the more we find. Large-scale surveys like SDSS, Sloan Digital Sky Survey, and space-based missions like Galactic and Chandra have catalogued thousands of interacting galaxies. We now recognize them in every stage: the first touch, the violent pass, the calm after, the merger. Each image is another note in the symphony, another line in the epic. These images have even reached beyond science, inspiring artists, musicians, writers. They appear on album covers, in poetry, in video games and cinema. Their forms have entered our culture, our imagination. For how could they not? To see a galaxy pulled into a stream of stars is to glimpse the hand of something far greater than ourselves, and in that awe, perhaps we remember something essential, that our Earth, our Sun, our species are all participants in this grand drama. That even as we go about our lives rushing through cities, whispering to loved ones, chasing meaning, we are riding within a galaxy that is itself on a journey toward encounter, toward transformation. Galactic collisions remind us that we are not separate from the universe. We are made of it. We are shaped by its forces, composed of its dust, guided by its laws. And when we look up, truly look up, we see not only stars, but time. We see our past, our present, and the silent echo of what is to come. Long after the dance ends, after the galaxies have merged, their stars have settled, their gas has calmed what remains. What do these titanic collisions leave behind, and how do those remnants echo across the cosmos? The answer is not absence, but legacy. Collisions do not erase galaxies, they transform them. In the aftermath of a merger, the new galaxy is often bigger, heavier, and rounder. Spirals become ellipticals, disks become spheres. These new galaxies are no longer birthing stars at the frantic rate they once did. Much of their gas has been spent or flung away in violent winds, driven by supernova and black hole activity. What's left behind is a population of older stars, glowing red and steady veterans of a cosmic war now at peace. These elliptical galaxies are scattered throughout the universe, monuments to ancient collisions. Some are giants, the largest galaxies in the cosmos, sitting at the centers of clusters, having swallowed many smaller companions over time. They are not dead, but they are quieter. Their days of brilliant, chaotic birth are over. And yet they endure. Like cathedrals, they stand as relics of past glory, still catching the light. But the legacy of a galactic collision extends far beyond shape. It is written into the orbits of stars, the chemical makeup of gas, the presence of unusual structures, shells, ripples, faint halos, all of which speak of past mergers. Astronomers can now trace these features backward, like archaeologists unearthing buried cities, reconstructing ancient events from scattered clues. In this way, every post-collision galaxy is a storybook of gravitational memory. There are other remnants to less obvious, but just as telling. Globular clusters, tightly packed balls of old stars, may be shaken into new orbits. Tidal dwarf galaxies, small galaxies formed from stripped-off material, may begin independent lives. And then there are rogue stars flung out of their galaxies. At incredible speeds, exiles born from gravitational chaos, traveling alone through intergalactic darkness. Even supermassive black holes carry the scars of these encounters. When galaxies merge, their central black holes eventually find each other, drawn together by mutual gravity. They spiral inward, emitting gravitational waves, ripples in space-time itself. If and when they merge, they send out a final burst, a gravitational chirp that will one day be detectable from Earth, with instruments like LISA laser, interferometer, space antenna. These are the whispers of the universe's greatest unions, and perhaps most poetically, the elements forged in the furnaces of new stars. Carbon, nitrogen, oxygen, iron are scattered widely in the aftermath. These are the elements that will eventually form planets, oceans, atmospheres, and life. Galactic collisions, violent and vast, are not just ends. They are the beginning of everything we understand as living. So when we speak of legacy, we speak not only of structure or light, we speak of inheritance. We live in a galaxy that has likely collided with others before. Our sun may have formed in the wake of one such event. The atoms in our bodies may once have spun through a star born of that clash. We are, in the truest sense, children of collisions, and what the galaxies leave behind is not just shape, not just silence, but the raw material for the next act in the cosmic story. The universe is not a still painting. It is a living history, a narrative of light, gravity, and time, unfolding endlessly in the night. Galactic collisions are not rare accidents. They are the natural rhythm of a universe that never rests. In a cosmos filled with billions of galaxies, motion is inevitable. Everything is falling toward something else, some slowly, some swiftly, but all guided by gravity in an unceasing dance. The cosmos is not a static museum. It is a symphony in motion. Even now, in the deepest reaches of space, galaxies are approaching one another. Clusters merge with clusters. Filaments of matter draw in lonely galaxies. Over billions of years, structures assemble and reassemble, building the grand architecture of the cosmic web, a vast network of galaxies and voids, stitched together by the pull of invisible matter. Everywhere we look, we find signs of this motion. Galaxies with tails of stars stretching behind them, shells and loops and halos, ghostly bridges of light connecting what once were strangers. We see future collisions as well, pairs of galaxies drawing closer, their fates written already in the alignment of their spin, their redshift, their slow approach. And yet, for all this movement, the universe is also expanding. Space itself is stretching, pushing galaxies apart, even as gravity pulls some together. This duality, the push of expansion and the pull of gravity, is what defines our cosmic age. In the early universe, collisions were frequent and ferocious. Galaxies were smaller, closer, wilder. The sky was crowded with newborn stars and chaotic mergers. Over time, as the universe aged and expanded, collisions became more selective. Larger galaxies absorbed smaller ones. Spirals evolved from clumpy beginnings. And in the far future, this motion will change again, one day. The expansion of the universe may accelerate so much that most galaxies drift beyond our observational reach, redshifted into darkness by the stretching of space. Only the closest companions, those gravitationally bound, will remain visible. The grand fireworks of galactic mergers will fade into memory. Cosmic history will become quieter, its pace slowed, its participants fewer. But the record will remain. In the structures left behind in the stars and black holes and chemical elements will lie the fossil evidence of billions of years of motion. Galactic collisions will have shaped everything: the structures of galaxies, the lives of stars, the birthplaces of planets, even the conditions for life, and perhaps, in the distant future, new observers beings formed long after us in galaxies. Yet unborn will look at the remnants of these collisions and ask the same questions we do now. They will study the shells, the rings, the tidal streams. They will search for meaning in the patterns, for stories in the starlight. And they too will discover that they are part of a history much older and grander than themselves. For that is the essence of astronomy, not just to observe, but to connect. To see not just stars, but stories. Not just galaxies, but relationships. Not just motion, but meaning. In the end, the universe is not static. It is a river, and galaxies are its travelers, shaped by the current, colliding in eddies, merging and dispersing, forever becoming. What do these immense, slow collisions of galaxies have to do with us creatures who live for less than a blink of cosmic time on a pale blue dot orbiting an ordinary star? Everything. We are not merely spectators of this grand cosmic ballet. We are its products. Every element that makes up our body's carbon in our cells, calcium in our bones, iron in our blood was forged in stars, scattered by supernova and recycled by galaxies through generations of mergers and collisions. The oxygen we breathe was cooked in stellar furnaces ignited during galactic upheaval. The gold in a ring on your finger may have been born in a neutron-star collision, another kind of cosmic merger. We are made of this violence. We are born of it. And just as we are made from these events, we are also shaped by our awareness of them. Our ancestors looked up and saw stars. We now look and see galaxies. We see motion, we see time, we see the past, and, in it, ourselves. To understand galactic collisions is to place ourselves in a much larger story, a story that began before our planet formed and will continue long after it is gone. It is a story without a clear beginning or end, but filled with transformation. Matter becoming form, form becoming light, light telling stories across eons, and in this story we find perspective, our conflicts, our divisions, our personal triumphs and tragedies, though important to us, exist on a scale so small that they vanish in the face of galactic time. Yet, paradoxically, this does not diminish us. It enlarges us. To be aware of the galaxies, to know that they are colliding, to understand what that means is to participate in something eternal. To be human is to ask questions about the sky, to seek meaning in the movement of stars, to turn knowledge into wonder. That's why we study these distant collisions, not only to understand physics or dark matter or cosmic structure, but to understand ourselves, our place, our origin, our fate. And it is why we tell these stories not just in science journals, but in documentaries, in songs, in whispered conversations beneath the stars. Because these stories, though vast, are not impersonal, they are intimate, they are emotional. They awaken in us the same awe that once lit the fires of myth, that once gave birth to gods and legends. Only now our myths are real. Our legends are written in galaxies. So the next time you look up and see Andromeda, remember, it is coming for us. Not in anger, not in destruction, but in union. It is our future partner in a cosmic dance, billions of years long, and in that thought, there is peace, a strange, beautiful peace. Because if the galaxies can fall into one another, collide, and emerge changed but still shining, then perhaps so can we.